Okay, Assalamualaikum. For this meeting too, we will show our progress each by each that we make. So for my part is for the actual experiment. So for firstly, I have this I have the equipment. So as you can see, I have this hose pipe, 10 meters. So this connection T, which is connect to three-way, and also a single connection, a single connector that each 1 meter or 2 meter, I will pop it this each, and also I will see the I will see I will refer to the report to actually insert this single connector to each length. So for the first part, I will show you that I have measured the length for 1 meter each, because for me, I easily measure 1 meter, and also after that I will measure 1 meter, 1 meter after that, because it's easy for me to get the result that I need. So for example, what we want to make is the straight line water hose. So the second is for closed loop water hose. So for the straight line, we have to use like 2 meters. Okay, we have to use this 2 meters each. For the first task that I have the actual experiment, we have to make the experiment for the straight line hose. So for the straight line hose, we need to have each of the length must be 2 meters. So I have connect each 2 meters the single connector, 3.5 meters, 3.5 millimeters of a single connector. I've connected to this 2 meters each. So by doing this, I can also using the same hose to connect the single connector to each length, like this one. For one loop, I have connect each like 1 meters length each. So for me, I will mark first each 1 meters, and then I will cut a small amount of hole for the first 2 meters, because if not, I have to do this only task. Which mean I have only one hose to do same task. So which mean I have to cut the first hole 2 meters, but I actually mark first. I actually mark 1 meter by 1 meter, and then after that, after each end. So for me, I will easily took 2 meters, and then I will cut small holes, and I will put the single connector to each 2 meters, and then I will do the same as the second hose, because the second hose, I will not cut the 2 meters length. Which mean if this part is like 2 meters, so I will not cut this hole, small hole, but instead I will cut before that. So before that 1 meter of that, I will cut a small hole, and then I will put the single connector. So actually we will use the same hose that we experiment with. For me to cut a small hole to this uh, to this hose, I will use this iron solder iron. So I will soldering a small amount of hole, and then I will uh, put a pressure a bit to this connector, the single connector, to connect with the hose. So it will not leak. It will not leak water, and also it will provide some of pressure water to burst each of the 2 meters that have poke uh, poke in the hole. So after that, uh, I have to measure the amount of water in 10 milliliters each. So I have to take the time taken for 10 millimeters for first, because I want to know if we not connect to the host that we experimenting. We need to show that how the time taken that we have measured, and also we can know the differences between them. So also I will take this I will take the time taken to ensure that for 1 meter, for 10 liter, for the time taken that water fill in the 10 liter of this bottle. So after that, I will measure the jet stream. So for the first, I will use this 1 meter of hose pipe to experiment the water jet, to know and to measure the water jet length. So after that, I have measured the water jet length using this measurement meter. So I have get like 3.5 meters between this line. So I have get like for the water jet, the difference is 2 meters from the end of the hole hose and the top of the tree. So after that, I have to do the experiment for the first task. So I have put I have already connect each single connector to each 2 meters, and also I have to straight the pipe, the hose pipe, and to make sure that all this single connector is uh, will will have a pressure to make the water flow out of them. So for the second task is I'm doing the one loop hole, or one loop. So one loop hose pipe. I have connect to this T connector. So as you can see, I have connect with extender hose pipe that actually is 0.5 meters, and connect with this 10 meters hose pipe, which is in one loop circle. So actually I have used this around my house, and also around this tree of mine. So actually it is pretty well flow, and also has a amount of water flow that each 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 1 meter, that flow is very high. And also I have to taken this time taken each hole that I have pop up. That's all for my presentation on an actual experiment. So I will give to the CDF simulation for Aiman to explain it.
Okay, so now I'll talk about the CFD simulation that we have obtained. So for the second task, we have two configuration, which is the first one, such as this one, which is the straight line configuration. And then we have the second one, which is a closed loop configuration. So as we can see in the first configuration, which is the straight line, it doesn't have a feedback. So the water just flows, and the only place that the water will flow out is on the tubes made on the hook pipe. And for the second one, we can see that when the water flows in here, it will go into both direction. And when the fluid fills the pipe, so there will be feedback to the system when the pipe is filled with water. Okay, so first we look at the simulation result for the straight line. So now, as we can see here, there's a red area in the curve here. So that indicates that there will be turbulence or kind of like disturbance or flow around that region. So we know that the flow will be affected around here. Okay, so now we look at the residual velocity of the flow of water inside the first configuration, which is the straight line. So as we can see here, the velocity decreases early on, and when it reaches the part here, that is the changing point of the velocity of the fluid in the pipe. So as we can see here, the velocity decreases, and after passing the curve, the velocity increases and become constant. So for the we have x velocity, y velocity, and z velocity. That determines the velocity of water in each direction, x, y, and z plane. For x and y, we can see that there is a small increase in the value. Is because the turbulence occurred at the curve, causes the movement of fluid to go into different ways. But if we look at the z velocity, which is the direction that the water flows, there was no increase in velocity. So when the velocity decreases, it just then slowly decreases, but in a constant way. Okay, and that's it for the straight line configuration. Okay, so now we'll take a look at a second loop configuration. As you can see here, there are 4 points where the flow of water will change. Okay, so this is the residual velocity for this setup, the closed loop setup. As we can see here, the velocity increases as the water flows in here, because it takes a longer time for the pressure to be filled. And as we know from Bernoulli principle, as the speed increases, the pressure decreases. So it will take some time before the water fills the tube. So that means increase in the velocity of fluid, and this point here marks that the pipe has been filled. So when the pipe has been filled with water, the pressure increases, and if the pressure increases according to Bernoulli principle, the velocity will drop. So as we can see here, the velocity dramatically drops until the end of the iterations. So we can see here about 4 to 5 spikes, which this is due to the corner, the curve, and the corner of the loop. Okay, so then we take a look at x and y velocity. The x and y velocity decreases because there's not much turbulence here. The only turbulence is around this point, where the water flow move from downward into sideways. Okay, so the movement of fluid is more smooth here after the pipe has been filled, and the only spike here indicates that there's a turbulence on this side of the loop. And so what I can conclude from the simulation is that the closed loop gives us a better reading for the result, because it is more sensitive to the changes of velocity of fluid in the pipe. Okay, that is what I can see from the simulation. Okay, next, on to the next member.
For my data that I have collect data taken and also the length of this experiment, I have given to this two of my friends, Afiq and also Nabil, for them to calculate and also to make the report and also finish the report, and also see what type of error that I make, and we can discuss it later on. So for this is just a progress of our meeting 2. So any thought you want to give, Afiq or Nabil?
Okay, so from my group member experiment, so me, Nabil, and Afiq will continue with the report progress. So this is for our project progress for now, and thank you.